Hi everyone, thanks for joining my session. And it's Luis from the Kaia Labs, and I'm currently taking a role of the core protocol engineer at the Kaia Labs, which is the high performance layer 1 blockchain based on the Asia region mainly. And today I'd like to share our experience and the implementation of the building the auction-based MEV protocol for the high-performance blockchain, which is the Kaia for our case. And we'd like to share our knowledge and insight and also discuss with you guys. So before deep diving into our MEV implementation, we first need to know the basic knowledge of the Kaia because the MEV protocol is really depending on its own settlement. I mean the blockchain itself. For example, Ethereum has its own MEV solutions, and Solana and Arbitrum recently they released the time boost and something like that. So the Kaia is basically the fully EVM compatible high performance blockchain, and we support any EVM tools like hardware foundry or something like that. And we are fast. We've been over 5 years, and we are better tested scalability, the 4,000 practically, and we marked over 8,000 transaction per second in the real world, and 1 second finality thanks to the BFT based consensus algorithm. And we also support various gas abstraction like the fee delegation natively, and also we recently released the native gas abstraction that can be used for the many Web2 users who try to use the blockchain with their own token, like the airdrop mini token or the USDT. Recently, we onboard the native USDT tether recently or something like that. So thanks to I think you guys are aware of the mini dApps by the Line mini dApps or the recent Kaia's many the token generated events thanks to the Line mini dApps and the native stablecoin. We expect the increase of the on-chain trading volumes, which naturally leads to the increase of the MEV activity. So basically, when the users and I know you are all aware of the expert of the MEV, but let me just briefly introduce the simple example of the MEV. So when the user send the last swap transaction to DEX, like the A token to B token, then there can be the price difference between the DEX or the pair. So other arbiters can capture the value and they can send the bank run transaction to extract the value, which is the MEV. So I know you're aware of the MEV, but just like here, the red box transaction is the user transaction, and if the arbitrator or searcher found the transaction is profitable, then they can make a bank run transaction or any other transaction that can extract the value from the user transaction, and they can broadcast the MEV transaction to the mempool and the broadcast to network and can be mined and earn the reward profit from the user transaction. And there are typically 3 types. The first one is bank running, which literally the run right after the user transaction. So red box is user transaction, and the searcher will send the transaction that will be executed right after the user transaction. And also there's the front running, which is executed right before the user transaction. And there is the combination of the bank running and front running, which we call sandwich. And usually user will suffer some price changes due to the front running and the bank running also get all together. So the issue of MEV from the perspective of the layer 1 blockchain engineers, layer 1 blockchain, since the Kaia is a layer 1 blockchain. So if this transaction have the same gas price, it's actually the first come first serve the style, and the searcher will send the tons of transactions to increase the chance of inclusion of their transaction because it's FCFS, and the MEV profit is quite centralized to the searcher, and the searcher usually requires lots of resource like the engineering resource or the node management or something like that. So MEV profit is quite centralized, and we cannot also prevent the malicious action of the validator because validator will finally mine the block and they can replace the searcher's transaction to its own transaction. So there can be 2 options. First of all, we can ban the MEV activity, which is very the naive approach and infeasible actually, because we are public blockchain. Anyone can send the transaction and anyone can see the mempool. Anyone can check the transactions on the blockchain. But instead, we can make the MEV be more fair and transparent and profitable for all ecosystem users. And this is what we want to do. So our core idea is to introduce the public auction market of MEV chances for the searchers and to distribute the the bid from searcher to all the ecosystem to enhance something like the liquidity, or we can use the tip for our whole ecosystem, like the making some fund or something like that. So before diving into the actual implementation, we first need to look our requirement. So actually, we are high-performance EVM blockchains. We have only 1 second to make all the bank run transactions and the transaction into the block. So we need first of all, we need the stateless auction client, which means the auction client is the independent server that processes the bid from the searcher and select the winner and send it to the network. But stateless means that we can remove the state part from the auction client server. For example, if we need a state, then maybe we need to update our client itself. For example, modify the gas client in the Ethereum, for example, or modify the Solana client like the Zero or something like that. But we do not want to that because we want to reduce the auction time, and the auction time heavily relies on the verification itself. And if we can successfully introduce this stateless verification, then we can reduce the auction time and we can have more auction bid from the searcher, and we can reduce the latency of the user, of course. And also, stateless auctioneer will help the client manager, the operator who want to operate the auction client, which enhance the decentralization of our MEV protocol. And we also want to make this as the sidecar feature, not on the consensus, not affect to our consensus. And we also need to minimize the node burden due to this MEV protocol. We do not make our consensus to work due to the MEV processing the MEV transactions or anything related to the MEV. So ideation is like the simple, as I said before, we need the stateless auctioneer, which is basically the independent server that processes the auction. So it processes the auction from when there's a request from the searcher. Searcher will send the target transaction and the bid, and the auctioneer will start the auction with a certain duration of time. We call it the auction interval. And send the auction result after selecting the winner, and send the final result to network, like the validator, to recast the inclusion of the bid result into the block finally. And we also need to verify if the CN, CN is the terminology used in the Kaia network theory. You can check the CN, you can understand CN as the validator. Verify that if the validator properly processes the winner's bid, it means that the validator can still ignore the output result from the auctioneer. They can replace the bid, or they can ignore the bid, or they can hide the profitable transactions like that. So we need to monitor any malicious action from the CN, not just processing the auction. And for the validator, they need to process the auction result received from the auctioneer, and they need to finally order and execute the bid transaction. So, yeah, this is basic the idea of when the transaction enters to the network, then the auction participant, who is the actually searcher or arbitrager, once they found the profitable transaction, then they like to insert their transaction right after the user transaction, like the bank running case. Actually, we do not explicitly allow the prone running feature to reduce any attack and any suffer of the user. Anyway, this is the overall structure. So you can check the red number and the green number. So even if we release the MEV protocol, there will be still some searchers who don't want to use our MEV, because if they use our auctioneer, they need to pay the bid. It means they need to split their profit to the ecosystem. So they try to avoid using our protocol. So there will be some non-auction searcher who will capture the transaction from the network and send the bank run transaction. It is still possible because we are public blockchain. And also there is the auction searcher who want to use our auctioneer system. They also capture the transaction. It is same, but they send the bid to the auctioneer rather than sending the bank run transaction into the network directly. So after the auctioneer receive the bid during the auction interval, auctioneer will select the bid, winner's bid, and send it to the network. I'm sorry again. The CN means the validator, and you can ignore the P and EN. Some like other, they are. You can just understand it as some RPC node like that. CN is the validator, and the other is just simple RPC client. And after that, we send the data to the auction wizard and check it for the auctioneer monitor, who verify the action of the validator itself later. But there's some problem. So as I said before, we need the auction interval to process the auction, because we need to accumulate some bid from the searcher to select the winner. So we cannot just send the result once we receive the one of the searcher, but we need to wait to get some searchers bids, enough bid, and select the highest bid and send it to the network. But we can think of this situation. So non-auction searcher will keep sending their transaction not through the auctioneer, but the auction searcher will send their bid to the auctioneer, but they need to wait until the auction interval. Then if the target transaction is already included in the network, and if the winner's bid arrive at the validator later, then their bid is just discarded, and no searcher want to use our protocol. So we must solve this problem to make the searcher to use our protocol first. So to do this, it's inevitable actually to introduce some delay. So we need some delay, and for this example, it elaborates more about the problem I shared before. So there's some interval. For example, we have 1 second block time. So there's a 0 millisecond to 1 second, and this time duration, the transaction during the time interval will be included in the the block. So if this transaction is profitable, then the searcher will send the bid through the auctioneer, and the auction result can be arrive at the validator before the mining. But after some time, if the searcher find this transaction is the profitable and send some bid to the auctioneer, then their bid result cannot be included in a block because they are last minute transaction just before the mining. So we need to solve this problem by introducing some delay buffer, which we call it the early deadline. So as I explained before, it's inevitable to introduce the buffer delay, which we call the early deadline. So the transactions arrived after the buffer, they cannot be included in this block, but the next block. To do this, searchers can send a bid for this transaction for not this block, but the next block. So in the auctioneer's point of view, there are the serial of the transaction on the user side, and they will be broadcast to the network, like the EN, which is the just RPC client, and they will send it to another peer node and the auctioneer, and they will finally arrive at the CN. But as you already know, this transaction arrived after the early deadline will be included in the next block. So we can guarantee to searcher that this transaction the bid for this transaction also will be included in a block with the target transaction, not just the bid alone. And actually, there are some other challenges we faced. So we actually need to prevent some abusing from the searcher and the validator. So if the searcher, for example, since we select the winner and send the winner's bid to the network, then we can think that the winner's bid will take the slot of the block in a block. For example, once we send the winner's bid to the network, then the slot right after the target transaction is allocated to that searcher. But what if the searcher can make their bid transaction will be always reverted? In the EVM transaction, revert means that nothing happens except the gas fee and none, something like that. So it means the bank running opportunity is still alive, even if we select the winner's bid. It means that if the searcher can make their bid always reverted, then they can send the alternative bank run transaction not through the auctioneer to the network to try to not pay the bid to the network. So this can be happened to ignore our auction system and try not to pay the bid. So due to this reason, we cannot let the searcher do everything, but we instead we borrow some idea from the EIP 4337. I will explain later. So, sorry, give me a second. Oh, it's really hot here. Anyway, we cannot let the searcher do everything, but instead we can make the validator to execute the bid on behalf of the searcher. It means that we can take control of the transaction of the bid from the searcher, and we make the searcher always pay the bid and the gas refund if the given core data, which contains the bank running logic from the searcher, is successfully executed. The gas means that since the validator is the message sender of the transaction, the validator will pay the gas fee first and get the refund after the searcher transaction. And all these things will be executed automatically, which means in the same one transaction. And we can also check if there is possibility that the CN the validator can do some abusing. For example, they can replay the searcher's bid to extract the bid from the searcher. They keep replaying it, but we can avoid this situation by simple nonce things, and we also can imagine the situation like the CN can manipulate the bid, and there can be another searcher, the auctioneer, who mimic the original auctioneer and send some bid to the network to interrupt the system. So we include the signature of the auctioneer client to verify the bid is legit and the bid cannot be replaced. So to implement this, we borrowed some of concept from the EIP 4337. So in the 4337, there's concept of the user operation, which is signed by the user, and the user send the user operation to the bundler, and bundler will sign the transaction and send the transaction through the bundler. So we can think of the user as the searcher, and the user operation like the bid, and the final bundler is the auctioneer client. So in here, same idea. The bundler will pay the gas first, and they get refunded in the single transaction in the entry point smart contract. And there can be some concept of the paymaster or something like that. And we do have similar concept. And we have the auction entry point, which manage the searcher's nonce to prevent the replay and to validate the bid transaction and execute the user's transaction, searcher's transaction, like the user of in the EIP 4337. And we also have the auction deposit bot, which manage the searcher's deposit and the withdrawal for the bid. And auction deposit bolt, we take the bid from the searcher and the gas fee also from the deposit. So in the auction entry point, there it will call the auction deposit bolt when it will take the bid and gas from the searcher. And this is the whole the diagram, simple diagram. So first of all, there's the auction transaction call. Please note that the message sender is the validator. So first we do some basic validation like the block number or bid amount and auctioneer signature and EIP 712 and searcher's nonce. And after the verification passed and we start the bid processing, we deduct the deposit from the searcher and take the bid to our fund and refund the gas to the validator or something like that. Check the validation and take the real bid. And the execution page is simply execute the call data with the call data from the searcher, and finally we get the gas refund. Actually, gas refund that happened here. So if any of the process other than the execution page failed, we all revert it. So you might have some question because if the transaction is reverted, then the validator will lose some gas fee. So to avoid this, we introduce some core client changes, but due to the time matter, I will skip that part. So sorry for that. So we can recap the auction process. First of all, searcher need to deposit some Kaia, which is a native token on the Kaia network, to the auction deposit contract, and the auctioneer will detect the new deposit event and register the searcher's address as the valid searcher. And once the registration is done, searcher will can send bid, and once selected as the winner, will send the winners the bid to network. And at the same time, auctioneers will accumulate the data of the bid and the block produced by the validator to use as the fraud monitoring explorer, bid explorer, and Grafana dashboard, which means there's some internal uses or the public information channel. And we will look into this step by step. So first of all, as I said before, the auctioneer subscribes the info of searchers from the smart contract. In the EVM blockchain, we can subscribe the event of the event occurred by the execution of smart contract. So there will be the predefined event in each smart contract, and whenever searcher do something, searcher interact with the smart contract, auctioneer will event listen all the activity on the network which occurred by the searcher. This is required since auctioneer is stateless. Auctioneer cannot directly query the state of the auction deposit bolt and the auction entry point, but rather it keeps the listening, subscribing to the node on the network. And the auctioneer will keep recording for example, searcher 1, 300 Kaia deposit, and nonce is 17, and so on and so on. And after that, to enhance the transparency, for example, there is some node provider who want to hide the transaction to get the all chance of arbitrage itself. It can hide. It doesn't broadcast the transaction like that. So, but they will eventually arrive at the validator, and we'd like to enhance the transparency, and we want to give the equal chance to the searcher. So to do that, we will listen the pending transactions, which there is a queue transaction, pending transaction, and the pending means the executable transaction that will be included in the right next block. And the validator will send the pending transaction to the auctioneer, and the auctioneer will also broadcast the the pending transaction to the searcher. And this is not mandatory, so if searcher have more information, I think that is impossible. But anyway, searchers do not want to waste their computer resources to subscribe the pending transaction. They can just ignore the result from the auctioneer and manage their own node client, like they watch their own mempool, something like that. And once the profitable transaction is identified, the searcher will start sending the bid to the auctioneer. And the bid is the simple RIP encoded some series of the data. There will be target transaction, of course, and there will be block number, sender, nonce, and to address, and the call gas limit, call data, bid amount, and so on, so on. And they will sign this RIP encoded data to prove the bid is really come from the searcher, and the auctioneer will verify the block number, signature, and nonce from entry point and bid amount. Like they have the same nonce as in the entry point, and they have the enough deposit to pay the bid and the gas. And after the auction interval, we estimate the auction interval like the 150 millisecond to the 250 or 300 millisecond. We are testing it currently. Anyway, after the auction interval, they will send the winner's bid to the validators, and the result will be the RIP encoded data. And the important part here is that it will include the auctioneer's signature to prevent the validator to receive the bid from other auctioneer who mimic our original, the verified auctioneer. So signature will be simple EIP 191, and the validators will verify the block number, searcher signature, auctioneer signature, and nonce from entry point and the bid amount. And after the validator receive the winner's bid and the target transaction, it will start ordering the transaction and the order of the transaction, and will execute the transaction if the validator is the proposer in that the view. I mean in a round and the block number sequence, which is the terminology used in the BFT. Anyway, they will order if the bid transaction 1 has the target of the bid transaction 1 is the transaction 2, then this bid transaction 1 should be inserted right after the transaction 2. If the validator insert this bid transaction, for example, after transaction 3, then it will be detected by auctioneer, and we can introduce some slash, or we can kick out this from the validator set to monitor the auctioneers, the validators, any malicious action. And final bid will be from is the proposer, as I explained before, and the 2 is the auction entry point, and so on, other information. So we covered a lot of the topic today, and I cannot put every single details in the slide due to time limit, but we actually covered a lot of things actually. And first of all, we look into the basic Kaia architecture introduction and the basic MEV concept and basic approach of MEV solution from the perspective of the Kaia network itself. And we covered the implementation from the overall design to some key challenges we faced, like the early deadline to ensure the bid result to be included in a block with the target transactions securely, and also prevent the abusing from this consensus, the validator and the searcher, based on thanks to the EIP 4337, 48744 is the protect sharding, something like that. And last of all, we look into the step-by-step auction process. And here are the references. So, and we actually open source project, so you can check all the code here. And the auctioneer code and smart contract will be public after the audit. And if you have some thoughts on having some arbitrage activity on the Kaia network. So we are actually planning to provide some playground for the searchers to test the MEV protocol, our auction-based protocol, and we also plan some bid refund event to reduce the risk of searchers. So if you're interested, please send us DM. You can contact us through the Louis Encrypted, which is my Telegram handle, or the Twitter, or any other channel you can use. And here is the ad here. So some of you guys may know that we are recently releasing the Line Mini dApps. Actually, the Kaia is the born merge of the Clayton, which is backed by the Kakao, and the Finxia, which is backed by the Line. So we are recently releasing the mini dApps, and it makes us as the most active EVM public blockchains on the network, and we have the millions, the 10 millions to 200 millions of the active users, and we are successfully onboard many builders, users, and we can provide some distribution channel with the verified user pool. So if you're interested in building the mini dApps and have some, if you want to onboard the millions of users rather than spending billions of dollars on the Web3 spaces, please join our movement together, and you can register your idea or project on the wave.kaio.io. And also, we recently released the Kaia stablecoin and the Tether USDT. We onboard the native USDT on our network, layer 1 blockchain, and we also prepare many things for builders and users to activate the stablecoin ecosystem on the Kaia network. So we are preparing the stablecoin summer hackathon. So if you're interested in building the stablecoin, the mini dApps or stablecoin things on the Kaia network with the millions of users, we have some builder support program for the builders, so please contact us if you're interested. And here's the link. We have, of course, X, and we have some dev portal for the Line Mini dApps, and we have Linktree link, QR code for the Linktree and the Kaia developers. So if you're interested, please check out all the information here. And Kaia is the Asia's super app chain and mobile-first gateway to Web3 to onboard many Web2 users onto the Web3. And please join our movement together. And this is quite all from my presentation. So if you have questions, please let me know. Yeah, thank you. No questions?
In the current model, there's no way for users to get refunded for their value, right? Like, for example, on mainnet, you have MEV blocker and similar protocols that return the value back to users.
I'm sorry, but could you repeat your question?
On mainnet, on Ethereum, you have multiple protocols that return value that users leak back to them. For example, in MEV blocker, when you do a bad swap, searchers will backrun it and refund the value to you. Is there any way to fit this into this model?
Actually, we do not have the direct refund to the user who suffered the large slippage, for example. But we rather than use the fund from the bid, which is actually the loss of the user, actually, we want to accumulate the bid to our own fund, and we to try to deepen our liquidity using that fund or something like that to enhance our on-chain DeFi the ecosystem. Yeah. Okay, thank you. You can continue outside if you have more questions. Thank you.